Welcome to momedaram. In this video, we will see linked list class. Linked list class is an implementation class for list interface. As we know, list interface is a sub-interface of collection interface, and this list interface has some implementations that are array list, linked list and vector. So linked list class is an implementation class for list interface. The linked list class in Java is an implementation of doubly linked list. So the underlying data structure for this linked list class is doubly linked list. In general terms, linked list is a data structure. Linked list is a data structure where each element consists of three things. The first one is reference to the previous element. Second one is the actual value of the element, and the last one is the reference to the next element. If you see in this diagram, it is having some elements. In this first element has three parts. So first part reference to the previous address, the first part reference to the previous element address, and this one will be the second part will be the actual data, and third one will be the reference to the next element. In this one, the first element will not have previous element, that is the reason it is pointing to the null. And the second element, here it is doubly linked list, that is the reason we are pointing to this element will have address of the next element, and this element is pointing to the previous element, that is this part is contains the address of the previous element. And here this is the last element, so the last element will not have the next element, that is the reason in the third part it is containing null. So this is how the linked list we will represent. So linked list class in Java is an implementation of doubly linked list. A linked list class contains a group of elements in the form of nodes. So we can say these elements in the form of nodes. A linked list contains group of elements in the form of nodes. This linked list allows duplicate elements. This linked list allows insertion order. So the elements you will be added the same way it will be stored. Allows heterogeneous objects. By using linked list, we can able to store the heterogeneous data, that is different type of data also we can able to store. This linked list allows null insertion is preserved. By using linked list, we can able to store the null values also. Linked list class implements serializable interface and clonable interfaces, but not random access interface. As we discussed, all collection classes implements serializable and clonable interfaces. Why serializable it is implementing? When we are transforming data from one state to another tier, it should be securely, it should be transformed. That is the reason we have to do serialization. Why clonable interface? When we are transforming data from one state to another tier, there they will not work on the actual data. They will be work on the cloned object. That is the reason they have implemented. This linked list is not implemented random access. So this random access implements only array list and vector in collection framework. So if you see in this screen print, linked list class implements list interface, DQ interface, clonable interface and serializable interface. Linked list constructors details. Constructor of linked list class provides many ways to create the linked list objects. By using the constructors, we can able to create the objects for any class. In the same way, linked list also has some constructors, that is linked list L is equals to new linked list of. This is a default constructor. This is no argument constructor. By using this constructor, we can able to create an empty list. This linked list will not talk about any default capacity, or once that it reaches max capacity, new size will be created, new capacity will be increased. Nothing like that. It will not talk about like that. Like arrays, it will talk about default capacity is 10. Once it is reaches its max capacity, the current capacity will be increased. It will be there, right? That concept is not applicable for this linked list. If you want to add elements, you can happily add. If you want to remove elements, you can happily remove. Linked in this screen print, if you see linked list L is equals to new linked list of, and when we are trying to print the size, it is giving 0. The second constructor for this is linked list L is equals to new linked list of collection object. This constructor is used to construct a list containing all the elements of the specified collection. So if you want to create an equivalent collection object like array list, if you want to create equivalent array list for this linked list, we can use this constructor. So by using this constructor, we can able to create a list containing all the elements of the specified collection, and this constructor may throw null pointer exception when if the specified collection is null. If you pass null as an argument, that time this constructor throws null pointer exception. So to create objects for this linked list class, we have two constructors, that is parameterized constructor. This the parameterized constructor will accept collection as an argument, and the another one is a default constructor. Generally, we use a linked list to implement stacks and queues. To provide support for this, linked list class has 6 specific methods. That specific methods only applicable for this linked list class only. We cannot able to apply these 6 methods to the another classes. That methods are add first. If you want to add an object to the list at the very first, that time we will use add first method. So add last. If you want to add an object to the end of the list, that time we will use add list. Get first. If you want to retrieve the first element of the list, that time we will use get first. If you want to retrieve the last element of the list, that time we will use get last. If you want to remove the first element of the list, that time we will use remove first. If you want to remove last element of the list, we will use remove last. So these 6 methods are applicable only for linked list class. So if you see in this screen print, we have created object for linked list. Linked list L is equals to new linked list of, and we have added elements L dot add of momedaram, null momedaram a 1 2 3 4 5 1 2 3.45, and we are printing this object linked list object we are printing. So if you see here, this linked list allows duplicate elements. Momedaram is a duplicate element, and it is allowing null insertion also applicable. And if you see here, we are inserting string, null, character, integer, float. So by using linked list, it can able to store the heterogeneous data. And if you see here, when you print this one, momedaram null momedaram a 1 2 3 4 1 2 3 4 5, the way we have inserted the same order, it is stored also. So all the properties what we have discussed about, by seeing this example we understand. So if you see here, we are adding an element at the specified index. So when you see here in the 15th index, the object is linked list is added. Add first method. This add first method, what it is does, it inserts the specified element at the beginning of the list. Add last method. This method appends the specified element to the end of this list. This method is equivalent to the add method. This add last method is equivalent to the add method. So if you see in this example, we have added the objects, and when we are printing, we are able to see the list is the way we have inserted. By using add first method, we have added first object as the we have added by using add first method. So if you see here, the first object is added in the first index position, that is 0th index, and we have added last object by using add last method. So this object is added at the end of the list. Generally, this add method also adds the element at the end of the list, and this add last also adds the element at the end of the list. So if you see here, this method is equivalent to the add method. Then what is the difference between this add last and add method? Is nothing. Both methods will perform the same operation, same equivalent, both are equivalent. If we talk about differences, this add last method is of type void method, and this add method is of type boolean. So if you want to add the elements to the linked list object, we have 6 methods. If in this example we are able to see add method, this will add at the end of the list, and add of index comma element. If you want to add element at the specified position, we have add of index and comma element. Here we are able to add the first position. Add first method is used to add an element at the first. If you want to add an element at the end, add of last is there. And we have two other methods. L dot add all of collection. If you want to add any specific collection elements into the end of the list, that time we will use add all method. And one more method is there, add all of index comma collection. If you want to add the collection of elements at the specified position, we have add all method. So if you want to add any element to the linked list, we have 6 methods. And the next method is get first method. This method, what it will do, it will returns the first element in the list. Get last method, this method returns the last element in the list, and this method may throw no such element exception if the list is empty. So if we have a list, if it is not having any element, that time it will say, hey, there is no method, how can I remove? That is no such element exception it will return. So if you see in this example, we have added some list, and we are trying to get the first element, and we are trying to get the last element. So here first element is momedaram. If you see here, we have printed momedaram is the first element. Last element is 1 2 3 4 5. So 1 2 3 4 5 is the last element. And if you want to get a specific position element, that time we will use get of index. So by using that get of index, we will able to get the whatever the data is there, whatever the element is available in that specific position, we can able to get. So if you see in this example, we have just created a linked list. There is no data is there, there is no objects is there. So when you try to get first object, it is giving no such element exception because there is no data available. And here also we have created linked list empty object, empty list, and we are trying to get the last element. It is giving no such element exception. And the next method is remove first method. By using this method, we can able to remove the first element, and this remove method returns the whatever the element it is removed. And the last and the remove last method, by using this method we can able to remove the last element of the list, and this method returns the whatever the element it is removed. And this method may throw no such element exception if the list is empty. If you see in this example, we have added some 5 elements. 5 elements we have added, and we are able to print the list. And when we apply and remove first and remove last object, this remove first element is remove the first element momedaram, and remove last method also it removes the last element 1 2 3 4 5. And when you print this list at the end, it is giving 3 elements only. So by using this example, we understand if you want to remove a first element, we will use remove first method. If you want to remove last element, we will use remove last method. So if you see in this example, we have created empty list and we are trying to remove the first element. It is giving no such element exception because there is no element. If we try to remove last element also, it will give the same exception, no such element exception. So if you want to remove an element from the linked list class, there are a lot of methods available. If you see here, remove first, it will remove the first element. Remove last, it will remove the last element. This remove of object method, it will remove the specified object. If it is repeated 2 times, it will remove the first occurrence. Remove of index, if you want to remove an object based on the index, we will use this method. Remove method, this method will remove the element at the last element. This remove method is equivalent to the remove last method. And remove first occurrence of object, This method removes the first, if object is repeated 2 or 3 times, this method will remove first occurrence one. If wants to remove the repeated element at the last occurrence, this remove last occurrence method will be removed. If you wants to remove all, if you wants to remove specific collection of elements, we will use the remove all method. So these many methods are there to remove an object from the linked list object. And now we need some observations here. We have created a linked list L is equals to new linked list, and we are trying to add few elements. When you add this one, when you run this one in the first statement L dot add of momedaram, what will happen? A new object or a node will be created. So this node first part will be pointed to the previous element, but this is the first element, right? So it will be pointed to the null. This is the first element, means here there is no element, the next element will not be there. So here also it will be pointed to the null reference also. And if you add the second element, it will be new node will be created, and this first element will be pointed to this one, and the second element will be pointed to this first element, like this. And if you add the momedaram we are adding, so new object will be created, and this second element will be pointed to the third element, and this third element will be pointed to the first element. And if we are adding 1 2 3 4 5 also, so here also it is pointing, this object is pointing to this object is pointing to this. So in our example, this is the last element, so there is no element will be there in the last, so that is the reason this third part is pointing to the null object. So this is how the elements will be, the linked list objects will be look like. Now if you want to add any element in between these two objects, how we can able to do? The object will be, we can able to add, and the references, this first object will be pointed to the newly created object, and this newly created object will be pointed to the next element, and this whatever the references are, right, that references will be removed. So this is how we can able to add an element anywhere. If you want to add first, the object will be, we can able to add this node, and this node will be pointed to the next element. And if you want to add the element at the last also, same thing, we will be added the node, and the last whatever the existing node is there, right, it will be pointed to the newly added node. So we can able to happily add any element easily. In array list, what will happen if you add an element? Whatever the elements existing objects are there, right, that all objects will be moved to the, they will be shifted to the right hand side. And if you want to remove an object in this linked list, you can happily remove. For example, you want to remove this momedaram object, or when you use remove, this object will be removed, and this whatever the previous element is there, right, this element will be pointed to the next element, and this next element will be pointed to the previous element. So remove also we can able to do happily. But when it comes to retrieval, if you want to check whether if you want to retrieve that data, or if you want to find whether the element is exist or not, that time what we need to do, we have to traverse either from beginning to end or end to beginning, because this is a double linked list, right? So we can able to happily traverse from first to last and last to first. But to find this object, we have to, for example, if you are trying to find from beginning, we have to check in the first element. If it is not matches, then we have to find the address of then we have to find the address of next element, and we have to find that element, and we have to compare. Then we have to check for the next element. So the searching of an object will be difficult. Difficult means it will take time consuming. It will the time complexity is more. So based on this example, we understand that if our frequent operation is insertion or deletion, then linked list is best choice. If you want to insert or delete, this linked list is best choice. So why? In the array list, if you want to add an element, when you add a new element, whatever the existing objects is there, right, all the existing objects will be moved to the right shift. And if you want to delete an element, all the existing objects will be moved to the left hand side. So but in this linked list there is nothing. In the linked list, just we will remove the references, and we will add the new references. And if our frequent operation is retrieval operation, then linked list is not recommended. Why? We have to traverse each element to find the element is there or not. So linked list is best for insertion and deletion, and it is not recommended for retrieval operations. This is all about this video. Thanks for watching.